Hello, we are going to graph this polynomial function. It's a fifth degree. So here we go. So to graph it, we're going to follow these steps. Apply the leading coefficient test, determine the X and Y-intercepts, determine the zeros, which are the X-intercepts, and the multiplicities. So first of all, we're going to apply the leading coefficient test. So the leading coefficient, our leading term is negative x to the fifth, which means the leading coefficient is negative and the degree is odd. So we have, okay, so here we go. Negative, odd. So this behaves like a negative x cubed. And negative x cubed looks like this. So negative x cubed is flipped like this. So that's a bad drawing, but we know it starts up and ends down. So that's what the leading coefficient test tells us. Obviously a big deal in graphing. So now we have to determine the x and y intercepts. Y-intercepts let's do those first. Those are easy with a polynomial. You plug 0 in for x. So when you look at this function, every part of it has an x, so you're just going to get y equals 0 plus minus 0 plus or minus 0. It's just going to be 0. So the y-intercept is 0. The x-intercepts, you plug in 0 for y, or f of x. That usually takes a little bit more work. When you see more than one x, like we have here, it usually means you're going to factor. Always look for a GCF first. So the greatest common factor, they all have x's. So I'm going to factor out the x cubed. But also notice that the first term is negative. So you'll want to factor out a negative to make that a positive one. It just is easier to factor. So I'm going to factor out a negative x cubed, and I'm left with positive x squared plus 8x and plus 16. So now you're going to keep on factoring if possible. So this one, you're going to notice either you look for factors of 16 that up to 8, and that's 4 and 4, or you notice it's a perfect square trinomial, you can do the shortcut. But I'm going to pretend I didn't notice that. I'm just looking for factors of 16 that add up to 8. So my x-intercepts are the solutions to this using the zero product property, x equals 0, x equals negative 4, and x equals negative 4 again. So my x-intercepts are x equals 0 and x equals negative 4. Those are also zeros. So now I'm going to look at the multiplicity of my zeros because that's very important in my graph. If it's even multiplicity, the graph will bounce off the x-intercept. If it's odd, the graph will go through the x-intercept, usually like this. So basically you're counting how many times the zeros happen. So the negative 4, you can physically see that happens twice. So I'm going to write my multiplicities right under the zeros. So over here, the multiplicity of negative 4 is 2. So that's a bounce. The multiplicity of x equals 0, even though it looks like it happens once, it's x cubed. So you have to think it's x times x times x. So each of those x's would produce a 0. So there's actually 3 of them there. But that's an odd multiplicity, so it goes through. So I also have this extra points as needed. We'll see if we need them. Oftentimes you do not, which is nice. So I'm going to start plotting everything. The leading coefficient test says this starts up and ends down. I'm going to just go start up and just go through my zeros and just be sure it ends down. If it doesn't end down, then I probably screwed up somewhere. So that will be like my last check. My y-intercept is 0. Then that also must be an x-intercept. I mean, you can just see that. So I took care of the y-intercept right here and the x-intercept. And the other x-intercept is -4, so I'm going to 1, 2, 3, 4. So remember, it bounces off this one. So the first one, it bounces because even multiplicity. The second one goes through because of the odd multiplicity. A polynomial graph has to be smooth and continuous. So I'm not going to have any jagged edges. I'm going to draw this as smoothly as possible. So, all right, so the first one, it must have bounced. Wait, I don't like how it's going, so I'm going to erase it and start over again. So the first one is going to bounce. So it's going to be a nice smooth graph. It's going to come back up and go through this 0 and then and it doesn't, there's no more intercepts, so it just keeps going down, which agrees with our leading coefficient test that it starts up and ends down. So that's it. Now, one other little bonus thing here. So I'm done with this problem. But if you want to see how high this goes here, because, maybe it does this, that additional points would be nice for that. Like, I'd like to see what happens around, say, -2. So if you want to figure out what happens at -2, you just have to get a point associated with -2, which means I'm going to have to plug in -2 here. So f of -2 would be -2 to the 5th minus 8 times -2 to the 4th minus 16 times -2 to the 3rd. So that is, if you're interested on how high that goes, that's a really good way to do it. I'm going to do that quickly on my calculator. You actually get 32 on that. So that's just additional information that you can use, which means though my graph was good, it shows you the right shape. This point at 2 should actually be way up at 32. So this graph really goes up high, but still comes down like this. So that's just something to consider when you're doing these. You don't need to do that at this point. We're just going for the shape. So hope that helps. And I'll see you during the next video.